All right, let's go over the chemistry final exam review study guide packet, starting with nomenclature. Um, so basically, before we even start, we have a lot of equations that you're given on the top right here, and these are all the equations that you're given on the test. So if we need equations, I will definitely go over them and mention if they are on the test and given to you here, or if they are not. So no worries on that. So let's start with nomenclature. Nomenclature basically is just a fancy word for naming. So in chemistry, we name compounds like magnesium chloride, lead 2 acetate, and we're going to go over how to name these formulas and compounds. So if it says if you're given the compound name, provide the formula. If you're given the formula, provide the compound name. Let's start off with magnesium chloride. So, in order to name this simple ionic compound, magnesium chloride, all you want to do is grab out your periodic table. On the back, you have a common ions with charges paper attached to it, and we want to look up the charge on magnesium. The charge on magnesium is a 2 plus charge. So I'll actually write this out for you since this is the first one we're doing. So the charge on magnesium is Mg has a 2 plus charge, and chloride has chloride Cl. It ends in an "ide", so we know it's just one element on its own. Chloride has a 1 minus charge. So this magnesium chloride, we want to look to make it neutral. For all of these, we actually want to make it neutral. So make neutral. So Mg2 plus and Cl1 minus, we need two of these, two Cls, to cancel out this 2 plus. Therefore, our formula for magnesium chloride is going to be MgCl2. And remember, capitalization matters. So I'll emphasize capitalization here. Capital M, lowercase g, capital C, lowercase l, 2, subscript 2. All right, let's go on to the second one. Lead 2 acetate. So lead is one of your transition metals, meaning that it can hold more than one charge. So there's various leads, say lead 2, there can be lead 4, and lead 2, lead 4. It's varying on its charges. So we want to make sure that we balance it correctly. So the compound name, tells us that lead 2. The Roman numerals in the brackets mean that you have a charge of 2 on the lead. Since it's a transition metal, we're going to let us see this as Pb, and this is going to have a 2 plus charge because it says 2 in Roman numerals inside. Acetate is going to be C2H3O2, and it holds a 1 minus charge. So in order to cancel the charge on the whole compound and make it neutral, we want to make sure that we have two of these, make sure to put parentheses, two of these, whole thing. So this whole thing, C2H3O2, is the whole acetate compound, or ion. So we need two of these. Therefore, our compound or formula is going to be Pb, and that has a 2 plus charge, and C2H3O2 in parentheses, close parentheses, and a 2 subscript. So the acetate has 1 minus charge, lead has a 2 plus charge, and so we are doubling the acetate into a negative 2 charge in order to cancel the whole thing out and become um, neutral of 0. Let's go on to nickel 2 sulfide. Same rule here, Roman numeral, it's a transition metal, so we have to look at nickel 2. So nickel, Ni, has a 2 charge, so we have a 2 plus. And sulfite is going to be SO3, and that is, that's a bad O, SO3, and that is going to have a 2 minus charge. So now we have a 2 plus and a 2 minus automatically, which is going to cancel on its own to 0, neutral. Therefore, our nickel 2 sulfite formula is going to be NiSO3. Let's try number 4. Dinitrogen trioxide. So this gives away that it's a covalent compound. And so the prefixes in the front will tell you how many of the subscripts you need to put. So nitrogen, dinitrogen means two, di is two, and trioxide, oxide means O, oxide, so O3. So your formula is going to be N2O3. All right, let's try phosphorus trichloride. So phosphorus and trichloride is given, and we know that um, based on our prefixes that we are going to have one P. There's nothing in front. We don't put a monophosphorus in front. That is not allowed. So monophosphorus is not allowed. So we have just regular phosphorus, P, and trichloride. Chloride is going to be Cl, and we have three of those because we have tri. So it is going to be PCl3. All right, number 6. Trisilicon tetranitride. Trisilicon tetranitride is going to be, we're going to start off by looking at the silicon. Silicon is Si, and we have three of those. So we have Si3, and tetranitride is going to be, the nitride is going to be basically nitrogen because we have "ide" in front of it. Same with chloride. Chloride, nitride. There's an "ide" in it. It's basically its own thing. Nitride. All right. So with this information, we basically know that our by the way, nitride, I put a negative on there, but it's a 3 minus charge. Just letting you know. Don't be confused. So tetra means four, so the prefix four is going to go there. N4. The official name for this is actually N4S Si3 officially, but for our chemistry 1 nomenclature purposes, we can just put Si3N4 because the final is multiple choice. So if it's out of order, you just kind of assume it's like that. So before we go on further, let me just clarify the prefixes in case you are still confused. So mono, di, tri, r, tri, tetra, pent, hex, hep, hep, and then oct, non, and dec. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 respectfully. I will keep that on there. It can be either non-a or dec-a as well. Octa, nana, deca. All right, so moving on to number 7, N2O5. We know that this is covalent, so we can just put the mono di-tri stuff in front. But of course, with mono, we do not put it on the first element because we just leave it blank if there's only one. But we have two, so we don't need to worry about that. I-nitrogen, there's two nitrogens. Pentoxide, pentoxide, since there is 5 oxygens. Let's try number 8. Number 8 is a good example of not including the mono in front. So we have one N, so we just put nitrogen, no mono nitrogen, that's not allowed, just nitrogen. And we have one O, so it's monoxide. The official name for this is also going to be nitric, that's a horrible R, nitric oxide. But you do not need to know this, of course. It's chemistry 1. You don't need to know it. So just put nitrogen monoxide and you're done. Let's take a look at number 9. CaBr2. So we have calcium and bromide. Bromide is part of Brinkelhoff. Brinkelhoff. Brinkelhoff is Brinchlhof, and these are diatomic, which means that on its natural state, it occurs in pairs of 2. So O is going to be O2, F is going to be F2, and Br is going to be 2 because it is diatomic. That is just something you should know. But let's get naming. So we have calcium and bromide. Bromide, as I've said, is a diatomic, so it has that 2. but bromide on its own is Br2. Therefore, we look at the charge on Ca. The charge on Ca is 2 plus, and bromide, Br2 on its, this is 1, bromide, Br2, has a charge of minus. So based on this, if we were given the name, we would have to calculate all this, and we would have to ensure that Br2 is, make sure that's the 2 minus. But for naming, actual naming compounds, we can just skip that. So all we got to do is put calcium bromide and be done with it. All right, number 10, SnClO3 4. So it might look intimidating at first, but when you look at it closely, it's not a very complicated compound. Starting off with Sn. Sn is tin, but tin, if you know, it's a transition metal, so we need the Roman numerals. The Roman numerals we saw in lead and nickel. We need that for tin because tin's a transition metal and it can hold multiple charges. We got to define what charge it holds. So for that, we look at ClO3. ClO3 is chlorate. Chlorate, ClO3, chlorate, holds a 1 minus charge. ClO3 has a 1 minus charge. And we have 4 of those. So basically, we have 4 minus as our charge of the whole thing here, excluding tin, Sn. Therefore, we know that tin has to be a plus 4 charge in order to make this whole thing neutral. Right, because ClO3 4 is going to be a charge total of 4 minus, so Sn has to be 4 plus in order to cancel this. With that information, we can write tin, open the parentheses, and write 4 IV in Roman numerals, and write ClO3 is chlorate, so we just put tin IV chlorate. And that is it. 11, last one. Cu2SO4. SO4 is going to be an ion. It's called sulfate. SO4 has a 2 minus charge. It's called sulfate. With this information, we can tell that SO4 2 minus has a 2 minus charge, but there's 2 Cus. So that means that there's 2 Cus in order to neutralize this 2 minus charge. Based on this info, we can assume that 1 Cu being copper, is 1 plus charge. Each Cu is a 1 plus charge. And we need to put the Roman numerals again, like tin, nickel, and lead, because copper is a transition metal too. So we put copper, open parentheses for the Roman numerals, and since we know that copper is a 1 plus charge, we can just write 1 in Roman numerals, which is I, copper, and then sulfate. So copper 1 sulfate is going to be your final answer. And with that, the naming is done. Alright, moving on to the laboratory review. Let's list reasons why goggles should be worn in the lab. Of course, goggles is a piece of important safety equipment in the lab, and everyone probably knows the main purpose is to protect the eye. Protect your eyes. And let's move on. So, moving on to Unit 1. This is going to cover chemical reactions. So the directions say to balance and indicate the type of reaction in the following equations. There are 5 types of reactions you need to know. Synthesis, decomposition, single replacement, double replacement, and combustion. I want to elaborate on each of these right here. So synthesis is going to be combining 2 things. So A plus B produces AB. Decomposition, as you can tell from the name, you're going from AB and decomposing into A plus B. Single replacement is going to be A plus BC. It produces B plus AC. Double replacement is going to be AB plus CD, produces AD and CB. And combustion, there are two types of combustion. So complete combustion, and incomplete combustion. Complete combustion is going to be basically C to the Cx. This is a subscript. It can be any subscript. So Cx uh, Hx plus O2, which is going to give you complete combustion gives you carbon dioxide and water. I'm running out of space here. H2O. All right. But on the other hand, incomplete combustion is going to be CXHX. Once again, these X's are subscripts. Sub any subscripts right there plus O2, and that is going to produce CO, carbon monoxide, and H2O. So that is the major difference between complete combustion and incomplete combustion is that complete combustion produces CO2, complete CO2, and incomplete is going to produce carbon monoxide, CO. All right, taking a look at number one here, we are going to determine our type of equation and balance it. So we have Pb as A, Cl as B, C as Ag, and D as NO3. Now we have Pb as A, and our NO3, the D has been moved, and Ag, or C, has been paired with B. So as you can tell, it is a double replacement because it is now ABCD and AD and CB. So it is double replacement. All right, let's balance this. So we look at where our arrow is, and we're going to try to balance it on both sides. So we want equal amounts of everything. We have one PB here, one PB here. We have one NO3 here, but we have one NO3 times 2. So we need to multiply this side, which applies to Ag and NO3. So NO3 we have 2 now, but now we have 2 Ags. So we look on the right-hand side, and we look at the Ag and say, oh, 2. And now we are finished, because now we have Pb, that's 1. Pb on the other side, that's 1, that cancels. Cl2 on the left-hand side. Cl times 2, which is Cl2 on the other hand, that's good. Ag times 2. Ag times 2, that's good. And NO3 times 2, and NO3 times 2 right here. And we're done. Excuse me. All right, moving on to the second one. We have NH3 plus HCl becomes NH4Cl. So we have A, we have B, and now we have AB as a whole. That is going to be synthesis, S. So we take a look at NH3 and HCl and NH4Cl. We're going to count how many of each there are. So we have one N, that's good. We have 3 H's and another H to total up to 4 H's, and 4 H's on this side too. We're good. We have one Cl and another Cl on each side, so we are all good. This is already balanced, so 1, 1, 1. And so a key thing to note here, I forgot to cover it, but if you haven't already caught on by now, it should be coming back to your memory. But we can never fix these numbers, like subscripts, we can never alter. The only number we can fix is these numbers up front. So how many moles of each compound there are. That is why we are doing this to balance this, because we can't alter any of the subscripts. We can only alter how many of each there are. All right, moving on to number 3. Number 3, we have Al, A, Cl, B, Na, C, SO4, D. All right, now we have on the other side Al, A, SO4, which is a D, Na, C, and Cl, a B. So AB, CD, AD, CB is equal to the double replacement formula. So we know that this is a double replacement. All right, let's balance now. We have AlCl3 and Na2SO4. So let's start with Al. Al, there's one here and two here. So we want to double this to make this Al2 and cancels with this. And this becomes Cl3 times, so 3 times 2 is 6. So we have 6 Cls on this side. We have only one Cl on this side. So we want to make this a 6. Now we have 6 NAs too. 6 times 1, this is an imaginary 1, so 6 times 1 NA is 6 NAs total. So we look here on the left-hand side and see that there's only 2 NAs. So what times 2 equals 6? 3. 3 times 2 equals 6. So 3 times 2 is 6 NAs, and 6 NAs on both sides, that cancels. And SO4 on this side has 3, right here on the subscript, and we just multiply this by 3 because of the number we put in the front, and this is also basically 3. Therefore, everything is balanced now. All right, number 4. We take a look at this. So H2SO4 Fe. So A is hydrogen, B is SO4, and C is Fe. And we have now A and C plus B. So although it's not very exactly similar, it's the same concept that the A comes the C here replaces the A. Therefore, it is a single replacement. In order to balance this, we can count off all the elements. So we have H2 on this side, H2 on this side. H is good. We have one SO4 here, and we have one SO4 here. We are good. We have one Fe here, one Fe here. We are good. So this is already balanced. 1, 1, 1, 1. All right. 5. We have C4H12 plus O2 gives us CO2 and H2O. So we know that CXHX, so the subscripts plus O2, it gives us, this arrow means produces CO2 and H2O, is combustion. We just have to figure out what type of combustion. Well, it produces CO2. The only thing that produces CO2 as combustion is complete combustion. So we know this is CC, which stands for complete combustion. All right, now we got to balance. There are steps to balance this. We always want to balance O last. Oxygen always last. We always start with C and H and then go to O. Let's start with C. On the left-hand side of the arrow, there's 4 C's. Right-hand side, there's 1 C. So we multiply the right-hand one by 4. Okay. We're going to ignore the 8 oxygen that was caused by 4 times the 2 on here for now. We want to balance the hydrogen next. Hydrogen has 12 on the left-hand side of the arrow, and only 2 on the right hand. So we have to multiply 2 by 6 in order to get 12. All right, so now we can double check that there's 4 carbons on each side, 12 hydrogens on each side as well. And now we got to balance O, the oxygen, and that's it. 4 times 2 gives us 8 oxygens. And we have 6 times 1. There's an imaginary 1 there. 6 times 1 gives us 6 oxygens. So in total, we have 8 plus 6, which is 14 oxygens on the right-hand side. 14 oxygens on the right-hand side. On the left-hand side, we only have 2. So in order to go from 2 to 14, we have to multiply by 7. So to do this, we have to give this oxygen here a 7. Let's double check. There's 4 carbons here, 4 carbons here, 12 hydrogens here, 12 hydrogens here, and 14 oxygens here, and 8 oxygens here, and 6 oxygens here, which gives us a total of 14 as well. So we are balanced. All right, let's go over predicting products for reactions. This may seem complicated at first, but the test is multiple choice, and um, these are basically all fundamental concepts that you do know. Just review. So we have KOH and H3PO4, and we are looking at what product would come. So we know that if there's A, B, hydroxide is one as a B. C for hydrogen, D for PO4. That's probably going to be switching with the K and the H. So the H is going to be paired with the OH, and K is going to be paired with the PO4. With that information, we can set this up. Um, sorry. Um, H is going to move. So H is going to move to H2O plus H2O here, and then it's going to be KPO4. When we write these, we have to be careful because um this is not balanced. PO4, if you look on the common ions with charges on the back of your periodic table, PO4 has a 3 minus charge, but K only has a 1 plus charge. Therefore, we need 3. Let's write that better. K. We need 3 Ks and a PO4 to make this a total of neutral 0 charge. And water, we know that O is a 2 minus charge and H is a 1 plus charge. There's two 1 pluses, which is a 0 automatically. So the products would be water and K3PO4. If you wanted to go a step ahead and try to balance this, you can. I will try for the first one, but for the next two ones, if it's not balanced, I'm just not going to touch it. Um, so for K, we have to count how many Ks there are. So we have 1K on the left-hand side, but 3K on the right. So we multiply 3 by KOH. But now we have 3 oxygens, 3 hydrogens, plus the 3 hydrogens here and the 4 oxygens here. So based on this information, we have a total of 7 oxygens on the left-hand side, 7 oxygens, and a total of 6 hydrogens on the left-hand side. So we have 2 hydrogens here. In order to make it 6, we have to multiply it by 3. And in order to make the oxygen 7, we know that we have 3 oxygens already here for multiplying and 4 oxygens here. So that's a total of 7 oxygens. And now we are balanced. Alright, for the second one, CaI2 plus CuNO3 2, we're going to look at the first 4, A for Ca, B for I, C for Cu, and D for NO3. And this is probably going to be similar to 1 here. So it's going to be a double replacement deal. So the Cu is going to replace Ca, and Ca is going to replace Cu. So writing this, it would be Ca NO3 2, because NO3, there needs to be two NO3s because NO3 is a 1 minus charge. Calcium has a 2 plus charge. So we need 2 of these to cancel this out to a neutral. And we will have CuI2. And because copper, Cu, it can hold both 1 and 2 charge. But since there's two I's here and it's diatomic, we're just going to put that I2 there. And since I has a 1 charge and there's 2 of it, so that we know that's a 2 minus charge, and so copper here is going to be a 2 plus charge. So if you were to write the name for that, it would be copper and then Roman numeral 2. So that's basically what it means. But for our purposes, these are the products predicted. For the third one, we know that's single displacement because Mg is going to replace Ag and Ag is going to replace Mg. So this is A, B, and C. So when this replacing occurs, we're going to have MgSO4, but we need to look at our charges and make sure it's correct. SO4, if you look on the ion sheet, SO4 has a 2 minus charge, Mg has a 2 plus charge. So we know that this is going to be neutral. So we're good on that. And we're going to have an Ag just a standalone there. So these are the products predicted for the third one. All right, last question, number 4. Write an equation to represent what happens when solid potassium iodide dissolves in water. So we did learn a lot of stuff throughout the second semester, but think very simple. So When you look at this, solid potassium iodide, we got to find out the formula for this first. Potassium is K, iodide is I, but we have a 2 there, but just iodide. But for our purposes, we're just going to put 1 because on the ion sheet there's no subscript. So iodide has a 1 minus charge, K, potassium, has a 1 plus charge. So K and I together are neutralized to a neutral charge, and we want to be neutral. So the formula for this is going to be Ki. If you did want to put this parentheses S to signify that it's a solid, you can. And water, we know that is a liquid, H2O. To symbolize liquid, we can put that little L on the parentheses in the bottom. Okay, so thinking very simple, we can basically write Ki solid plus H2O liquid is going to be producing, and we're going to do A, B, let's write that in different color, hold up. A, B, A for K, B for I, C for H2, and D for O. Um, just quickly remembering that water is special, so let's erase that CD real quick. Water is going to, sorry, I'll write it on the side. Water disassociates as an H plus and OH minus. So this is something you should know. Water disassociates as H plus and OH minus. So actually, H plus is going to be our C. OH is going to be our D. But for our we're just gonna write like just put a C here and a D here, and we'll just pretend like we know what this means. All right. And so when we do a double replacement, we're gonna do flip out the first parts, and it'll replace each other. So when we do that, if it comes one H comes along and the other remains as an OH, because like this equals water. So this H is going to replace K, and this OH is going to stay here. All right. It's a little complicated, but we can do it. H replaces K, so it is going to be HI. H has a 1 plus charge, I has a 1 minus charge, and that is neutral, so we are good. So HI, that becomes aqueous, AQ, meaning it's been dissolved in water, plus we have an OH minus left from water, and an K left from our Ki. So these will combine together to form KOH. K has a 1 plus charge, OH as a whole has a 1 minus charge. Therefore, this is neutral, and it is also going to be AQ. So based on this, representing what happens when solid potassium iodide dissolving in water is shown. So let's erase that ABCD on the bottom. And this is going to be our final answer. And that is it.